Hi, look, today we're going to do a bit of a tutorial on using the igneous rock identification flowchart that you've been looking at in class. This one's from the Society for Sedimentary Geology. There are lots of other flowcharts that you could use. This one's pretty simple, straightforward, and it's specifically looking at the two key identifiers for for igneous rocks, which is colour and grain size. All right. So where do we start? First of all, let's talk about grain size. Now, there are different ranges of grain size. We talk about fine grained, medium grained, coarse grained, and then sometimes if it's super fine, in fact it's got no crystals at all, we talk about it being glass. Now, we've been covering in class that the rate of cooling is the thing that controls the size of the crystals formed. Intrusive rocks cool slowly beneath the Earth's crust, and therefore they form bigger crystals. Extrusive rocks cool more quickly on the Earth's surface, and therefore they're forming smaller crystals. Now, extrusive rocks, there's a whole spectrum of different grain sizes, with one end member being these glassy rocks that have cooled so rapidly, almost instantaneously when they've been exposed to the atmosphere, and they just don't have time to form crystals, so they're just forming glass. So those are the key things to remember: coarse-grained, fine-grained, glass. So then the other thing to think about is colour. Now, the table down the chart down the bottom here is just for illustration purposes, as far as it's showing the types of minerals that you might get in the different types of intrusive rocks. So starting on the left-hand side with the felsic rocks, we're talking granite and rhyolite, moving across to the more mafic rocks. And what does that mean? Mafic means that it's more magnesium, iron rich. Felsic is more sodium, silicon rich. So just talking through that. The colour of an igneous rock reflects the nature of the minerals present in it. Dark iron and magnesium rich minerals dominate in mafic magmas, producing dark coloured rocks. Basalt, gabbro are two classic examples. It's not to say that iron and magnesium minerals are the only minerals we see there, but they are the ones that are giving it the colour. Similarly, in light felsic rocks, we're getting a lot more quartz and feldspar minerals. So the feldspars, specifically the potassium and sodium rich feldspars, and that's giving us light coloured rocks, so rhyolite and granite. Cool. So let's look at an example. So we've got the flowchart up on the left hand side there. We've got a range of different grain sizes starting on the left hand side in the yellow. So first up, about this picture that we've got here, you can see that it's full of holes. There's lots of pores and bubbles and things in it. So this is what we refer to as a vesicular rock. So it's very lightweight. Many of you will have seen this in class. This rock will actually float in water. So it's vesicular. It's cellular, full of holes, and often very lightweight. Now, what does vesicular mean? Vesicular is the rock is pitted with many cavities in its surface. It's basically representing fossil bubbles of volcanic gas that are trapped in the rock. The second thing to note is it's a very light colour. So it's almost white. You could almost maybe say it's cream, but let's say it's white. But we could all agree that it's a very light colour. So you can see on the chart on the left-hand side that we're heading down one path there. Looking closely, if you can get a broken face on this rock, you'll see that there's shiny, glassy slivers in the fresh faces, and these are forming the walls of the bubbles. So emphasis there on glass. So, and there's rare, fine grey crystals. You can see a scattering of them there, but they don't make up a large proportion of the rock. They're not particularly significant in naming this rock. No surprises, this is pumice. All right. So let's look at another example. Again, many of you will have seen rocks similar to this. It's very dark. But the other thing, the key thing to see here is the fracture. What does it look like? Well, it looks like a piece of glass. If you break a bottle or something and look carefully at the broken faces on that bottle, you'll see that it's this sort of fracture, this sort of glossy conchoidal fracture. So we've got a glassy appearance. It's black colour. This sort of rock can be red or brown, but it's black in colour. It has this conchoidal fracture. So we're talking about a curved fracture. You can see them there. If I move the mouse, so you're looking around in this sort of fracture here. Yeah. What does conchoidal mean? It's a curved breakage or fracture that resembles the concentric ripples of a mussel shell. So if you think about a shellfish that you might find down the beach. And it occurs in amorphous or fine-grained rocks and with no planar surfaces of weakness. Those planar surfaces of weakness would be provided by crystals. So, no surprises, this is obsidian. Alright, so let's look at one that's maybe slightly trickier. So, we're looking at a fine-grained rock here. You can see the coin on the side for scale. It's a fine-grained rock. So, we talk about something being aphanitic. There are rare coarse crystals up to 2 millimeters, but mostly it's this fine-grained. So, what does aphanitic mean? This is a new word. Aphanitic are they're rocks that are so fine-grained that their component minerals are not detectable by the unaided eye. You're going to need a microscope or a hand lens or something to try and identify these minerals. So it's aphanitic. So it's dark grey in colour. Alright, and then it's massive, so there's no obvious internal texture. Sometimes these rocks can be vesicular. This one isn't. Could be vesicular, so it might have some of these bubbles in. This one doesn't. No surprises then. This one is basalt. So you can see what we're doing here. We're just starting with the grain size. We're saying it's fine grained, glassy, whatever. Then we're looking at the colour of it. And very quickly we come up with a name. One final example then. Here we have a coarse grained rock. This is what we refer to as phaneritic, so the crystals are up to 3 millimeters in size. Phaneritic refers to crystals that are rock that are large enough to be distinguished with the unaided eye. You can see them here as individual feldspar crystals or the darker mafic minerals that are visible, making up a large proportion of the rock. So it's essentially a dark grey colour. Yes, there are the white minerals, but collectively it's quite a dark colour. This one, look, it does have some light minerals, but the light crystals are all feldspar. If you look closely at this, you'll see there's no quartz. So if you went back to that chart that we had before, there's no quartz. So we're not at that felsic end of the chart. And this one is, surprise, surprise, a gabbro. Okay then, look, I hope that's helped. We're going to be using this chart a bit more, and we're going to be using similar charts to refer to as far as describing metamorphic and sedimentary rocks. The key things you need to be noting and recording are the grain size and the colour of the rock, and then of course trying to name that rock using the chart. Okay, thanks for that.